Yeah, so for those that doesn't know me already, I guess quite a few in the room might already. I'm Martin. I'm the founder of Scandinavian Drone, and we are happy to be one of the YellowScan distributors based in Scandinavia, as the name might already imply. So back in mid-February or something like that, or already in January, directly after the release of the Navigator, I have to say we got basically the most interest I think we've ever received for a new product launch. It's really, really mind-blowing. We already knew a little bit about the Navigator from before, so we had some conversations with a few customers of ours about it, and as soon as it went public, it just was basically like a storm of continuous inquiries, and it's still ongoing basically. So it was quite clear that there was a really big interest for a demo in our region, because most people are quite skeptical, I would say. They think that it's not going to work in our waters. We have such dark and murky waters. So felt like it was a lot of skepticism, but at the same time a huge amount of interest and curiosity. So we were, of course, bugging everyone at YellowScan to try to get the demo unit as soon as possible up there. And one happy day, I got the call from Camille, and she told me that it's going to be one available in a few weeks. So we immediately started talking to some of the customers who were really, really interested, and were able to organize this demo event in the southern parts of Sweden. So basically the first area that we got to look at was an area with a harbor, where you have this river mouth coming out, where they do basically annual dredging and clearing out of a lot of sediments that gets pulled out from the river. So that was one of the use cases, and then we did a few other ones. So we were able to scan basically 2 different harbor areas and a couple of other ones. So I'll speak a little bit about what we did and what was the basic objectives of the demo days and this opportunity. So in general, not everyone, but quite a few knows the workflow of a YellowScan system, and with the Navigator we're very familiar with it already as a YellowScan dealer. But one of the objectives with this opportunity was to basically show the workflow. How do you collect data? How do you process the data? And all of this. And of course, for both us and most of the customers, bathymetric LiDAR is really new. Almost no one has been working with it. So one very important thing for us as well was to really gain the experience, get to know what's actually realistic to do with it. Can we do this? Can we do that? Or is it just not going to be possible? So for us, probably one of the most valuable things with this opportunity was to gain a lot of experience, to be able to talk to a customer and tell them, yeah, this is probably going to be possible, or it's not a chance at all to do this. And kind of also then manage the expectations for customers who are actually interested in the Navigator. And of course, in most cases, the alternative is going to be echo sounder, multi-beam. So for us, it will also be very important to see what are the benefits and downsides of using a system like the Navigator compared to a multi-beam system. See what type of data you will get from it, see how the workflow is, both in the field and also in the post-processing of the data, and also see a little bit how efficient is LiDAR compared to multi-beam in different scenarios. So hello? Yeah, went back again. Yeah, so these were the main objectives, basically. And in order to do these flights, some of you already recognized it on the previous slide, but we used a drone from Hexadrone, who's almost local to this area as well, a few hours away. A very, very solid drone platform that's very flexible. So the Tundra 2 is the drone we have to carry the Navigator. To do the actual mission planning, we were using UGCS software. Probably quite a few are familiar as well with UGCS, Universal Ground Control Station, being used for both DJI drones and a lot of open source systems based on Ardocopter and so on. And as a base station, we use the MLID Reach RS2. That's been a nice little rover / base station that we've had for a few years. So that was the basic setup of equipment that we had. And for those of you that doesn't know the Tundra, just a few quick specs on it. We had the endurance version, which is the one kind of the mid-range in terms of size, payload capacity. Can carry up to 5 kilograms. So it basically carries the entire YellowScan range, and it's kind of the sweet spot for us. With the Navigator, we can expect around 30 minutes of realistic flight time. Same goes for the Voyager. We've actually tried this as well, and we can see that it really performs that well. It's IP rated, it can handle quite a bit of wind, and best of all, it's extremely adaptable. You can basically customize it back and forth. You can have smaller motors for more agility, and you can have larger motors for even more payload capacity. You can add a lot of sensors for terrain following, obstacle avoidance, and so on. So it's basically up to you how you want to customize the system. So it's really nice platform for us. And to do the actual flights, as I mentioned, we use UGCS. It's a screenshot here. And for most of the flights, we did quite a few flights at different altitudes and so on, but the one that I'll focus on here, we did basically 60-meter altitude, approximately 5 meters per second in flight speed, just a single trajectory back and forth with a target of 50% overlap. And that was, this is a very nice picture of Roberto doing Secchi measurements. Being Italian, it's very natural for him to take this responsibility. It's probably one of the key elements of the entire operation. So, as you can see, he has a very good form as well with bending the legs and keeping the back straight. So I think it's very nice. But yeah, but you still see Pierre there rushing out, being a little bit skeptical when he leans over the water. So I think he wasn't completely confident, but it turned out well. He's still alive. So, but anyway, when we arrived to the site, we spent 1 or 2 weeks ahead of time trying to plan and what to do when we got there. But as always, when you arrive to a site, no one had been there before physically, so we arrived there, we assessed the conditions, make sure that it actually looks the way we think it looks in reality and so on. Start rigging up the equipment and getting ready to collect some data. So everything went well, as I mentioned. We did quite a few flights, and ideally, if we look at the water conditions, this would be ideal. I don't know how well you can see it, but during wintertime, it's relatively clear water, actually. So the Secchi depth was actually not that bad. We have quite a mixed bottom. As you can see a little bit here, I don't know, you can see we have quite a bit of sand bottom, and then some rocks that starts becoming a little bit darker. And then in some areas as well, more and more plant and vegetation underneath. And all of that, of course, is going to be very important for getting returns, not only the turbidity, but the reflectivity of the bottom. So in most cases, it can be very clear unless you're having storms or you have, for example, rivers and things like that pulling out a lot of sediments and things in the water. So it can be pretty nice conditions, actually. During summertime, it's a little bit worse with a lot of algae and things like that in the water. So this was good, pretty decent conditions, except from this little river mouth that we wanted to catch as well. So this is basically what it looked like where Roberto was checking. So there was a lot of wind, there was a lot of rainfall, and the snow has been melting, and that in turn pulled quite a lot of sediments and things like that out from all of the agricultural land. So in this river mouth, I'm going to show you in one of the screenshots later, you can see how brown the water was compared to on the outside of this. So that specific area where the river enters the sea is really not the ideal conditions. So for a couple of the flights where we did this surveying, we had about 18 minutes of flight time from the takeoff to the landing. And from that, we extracted about 11 minutes of data, covering approximately 400 by 150 meters in one of those flights, which gives you 60,000 square meters. So it's a decent, you can get a pretty decent coverage with this method. Point density, this is a rough estimate, so don't hold me to those numbers exactly, but approximately 15-20 meters per square, or points per square meter, I'd say is realistic. And of course the flight altitude and the speed can change this, as well as new algorithms improving the extraction of points in the future. So the big question that everyone always asks, and I'm hoping to get at least a couple of guesses here on how deep we got with the system. So anyone dare to give a guess? 2? 2, 4, 5? 3? You want to know? Approximately 7 meters was what we got here in the end on one of the areas. You can see it shows 8 meters. It's not the exact, but if you look down here at the set, you can see 7.3 meters in this example. It's quite possible we could get deeper as well. This is basically at the end of the flight lines all the way out there. So. It's not too bad, actually. I think it's a pretty good example that it's not that bad. Here you can see another one, same data set, just with the surface turned on as well. You can see about 7 meters. You might see a little bit of loss out here, that we're starting to get a little less intensity in returns, but at least it gives you a pretty good idea of what's possible. Up here we have just a top-down view of the same data set from one of the harbors. Shows you I think it's a very nice color. It doesn't represent the boring water we have. It's more like you're at the Côte d'Azur or something like that. It's very nice turquoise surface class color. And if we remove the surface and just tweak the histogram a little bit on the, so this is basically the bottom. You can see very clearly here some shapes of the water, how you see some of the dunes here, or the sandbars going across. So it's going to be very easy to see how these might move over time. And the same, you see the inlet to the harbor here. see very clear shapes of where you have a lot of traffic in and out. So I think it's for me, this is really kind of mind-blowing how you can just reveal something that you haven't been able to see. And the fact that you're getting, compared to multi-beam data, where you would basically only get the bottom, here you get everything. You get the context of what you're looking at, where it's located, with the surrounding area and the structure on land. So I think it's the visualization of the entire scenario and the entire environment compared to using multi-beam data. It's something completely different, in my opinion. And if we just switch over to intensity view, you can also, at least I imagine in my head that you can use this for a lot of things as well. Seeing what type of bottom conditions you have, if it's like here where it's mostly very bright sand, and then you go, of course, deeper, but you can also see in areas where you have the same depth, you can see very different intensity values. Same goes up here, where people are probably going full speed out of here. You can see that it probably clears the bottom from a lot of growth and vegetation as well. Someone correct me if I'm wrong, if this is not the way to look at it, but I think it can give you a lot of insights. Here you see the same as well. You see this breakwater and little pier structure with the cross-section. And for those that are already familiar, the water surface and the bottom, and then non-terrain class for those ones. So I think once you start moving around and looking at the data from different angles, different perspectives, and start working with it, it can definitely derive a lot of good information. So some of the applications to use it for in general in this type of scenario would say just creating a complete digital twin or digitizing the entire harbor and surrounding area. And for this, you can use it to a lot of things like construction work. If you're going to do maintenance, repair, or modify, rebuild something in the area, you have the perfect data to start working with that. Of course, a very natural thing to do is dredging in the area. So here you're going to get a lot of good before and after data for that. I can also imagine in insurance cases, if there's a big storm, you have a lot of damage or things like that, might have a lot of stuff ripped down and lying on the bottom or things like that. So I believe insurance can also, or insurance companies can have interest in this as well. When it comes to things that might be below the surface that can hurt either boats and ships going in and out, or people diving from the dock or whatever, identifying hazards like people, they drive cars over the edge and dump garbage as well. So seeing different things that's been dumped inside the ocean can also be pretty good use case. And just before I mention this this other area where you have this river mouth, you can see the difference in color here as well, and that's also a very nice benefit of having RGB colorized point clouds, that it gives you even more context to what you're looking at. You can see how clear the water is out here, but then it's really brown, and it kind of washes out here. So also give you a very good representation of things like that. A couple of more applications in general that's related more to environmental things, looking at erosion, how the sandbars are shifting, what type of bottom conditions you have. A little bit back to the look at the intensity view, look for underwater vegetation. I think you can't do everything, but if you start working with the data and compare it to some other things as well, you're going to get quite a few insights that you might not get with things like multibeam. So if I'm going to just sum up a little bit, a few takeaways from what we've experienced with the Navigator and all of the interest that's come from the release. I think it's definitely a paradigm shift for this entire niche, so to speak. It's with the Navigator, suddenly bathymetric LiDAR becomes accessible, becomes easy to use compared to most other systems. I think it's yeah, I'm not going to use the word. You can probably guess what I'm thinking, but it definitely draws a line in the sand before and after the Navigator. That's my opinion. It's super exciting. It's something new. It's a part of LiDAR that most people have never experienced and wouldn't have experienced without YellowScan pushing the boundaries. So I think this is going to be a huge thing going forward. It has enormous potential in so many different areas, but still there's a lot of things to learn. Many of us, or probably the majority of us, have never worked with bathymetric LiDAR or things like that. So there's a lot of things to learn about it, but I think that's what makes it very exciting as well. It's something you can really dig deep into and look at all of the different aspects of using it and interpreting the data, improving it, and so on. So really, really big thank you to all of the guys from YellowScan who's been working on this really, really hard for a long time. It's exciting times, I think. And that's basically everything I had to say right now. So if there's any questions or if there's anything else, you can feel free to shout out now or come and chat with me afterwards.